question 19 of the worksheet on forces and motion. Particle P and Q are moving in a straight line on a rough horizontal plane. Frictional forces are the only forces acting on these particles. Find the deceleration of each particle given that the coefficient of friction between P and the plane is 0.2 and between Q and the plane is 0.25. Okay, so we have two particles P and Q, and this coefficient of friction mentioned here, it's 0.2. And for this surface or this particle, it's 0.25. Let's say this is the direction of motion of both the particles. Then we'll have a friction in this direction, mu r. In this direction, mu r. There's no forward force, so zero forward force for both the particles. And we're going to use Newton's first law, which is, second law, forward force minus backward force is equals to ma. So let's discuss particle P first. Forward force is 0, minus backward force is mu r. Mu is 0.2. R is the normal contact force, which is going to be equals to, it's in this direction and it's equals to the weight of the particle. So let's say the weight is mg. So the R is going to be mg, and remember G is 10. So we write 10m here, is equals to mass times acceleration. Okay, so we have minus 2m is equals to ma. M and m cancels out. Acceleration is equals to minus 2. And deceleration is equals to 2 meters per second square. With deceleration, we do not mention the sign. Okay, so for this particle, acceleration is minus 2. Okay, for the other particle, same formula, forward force minus backward force. Backward is mu times r. Again, r is in this direction, opposite to the weight, which is 10m. So times 10m is equals to ma. Again, m and m will get cancelled, and acceleration is equals to minus 2.5. And that means deceleration is equals to 2.5. So for the second particle, the deceleration is 2.5. Okay. First part is done. At a certain instant, P passes through A and Q passes through B, and the distance AB is 5 meters. Okay, let's draw this. So, at a certain instant, particle P passes through a point A, particle Q passes through a point B, and the distance between them is 5 meters. The velocities of P and Q at A and B are 8 and 3. So here it's 8 and here it's 3. Respectively, both in the direction of AB. So both are traveling in this direction, same direction. Find the speeds of the particle immediately before they collide. Okay, so this would be U. And we need to find V's of both the particle, VA and VQ. Okay. Now, right before they collide, this distance, whatever is the gap between them, should be equals to 0. So we need to form an equation of the gap between the two particles at a time t. And when we'll equate the gap to 0, we should be able to get the value of time at which the gap is 0. Okay, so as the particle moves, let's say this is the distance covered by particle P, and let's say this is the distance covered by particle Q in time t. And then this till here is the gap between the particles at time t. Okay, now I need to form an equation that has 5 in it distance covered by P, distance covered by Q, and the gap in it. So if you look at the figure, that should be, if I add distance covered by P plus the gap, this should be equals to, so distance covered by P plus the gap at time t is equals to this, 5 meters plus distance covered by Q. Imagine this particle is very small, so these lengths would be like extension of each other. Don't get confused by this big circle I've made. Consider it to be a dot. So then this would be 5 and this would be S. So 5 plus SQ is equals to SP plus gap. Make gap the subject. So we have 5 plus SQ minus SP. Now, formula for distance of P and Q would be, we can use S is equals to UT plus half AT square for both the particles P and Q. So it'll be 5 plus for Q, U is 3. So 3T plus half. Its acceleration was, for Q, the acceleration was minus 0.25, sorry, minus 2.5 times t square minus ut would now be 8t plus half, and a for the particle p was minus 2 t square. Okay, this would be 5 plus 3t minus, this would be 2.5 upon 2, which is minus 1.25 t square minus 8t plus t square is equals to gap. Now we're going to equate the gap to 0. That is when the particles collide. And we're going to find the value of t. Okay, this would be minus 0.25 t square minus 5t plus 5 is equals to 0. I'm going to multiply this with minus 1 for convenience. And then apply quadratic formula on this to get two values of t. That's going to be t is equals to minus b plus minus b square minus 4ac over 2a. This would give you, when you solve this quadratic equation, you should get two values of t, 0.9544 or minus 20.9544. Okay, this has to be ignored because time cannot be negative. This would be the value of t we'll be using now. So at this time, both the particles gap is 0, and that is when the particles are just about to collide. And now we need the final speed at this point. So for P and for Q, we have the values. For P, U was 8 and A is minus 2. And now we have time 0.9544. And we will find V using V is equals to U plus 80. So 8 minus 2 times this answer, which gives 6.09. So this is the final speed of particle P. Similarly for Q, U is 3, A is minus 2.5, time is the same, 0.9544, and the speed at this instant would be, this is Q, sorry. V is equals to U plus A T. So that is going to be 0.614 meters per second. Okay, these are the final answers.